negative 1 is right here. Okay, that's where your horizontal asymptote is. So we also have y and x intercepts, right? In our function. So what we can do, let's find the y-intercept first, because all we have to do is really plug in 0 whenever you see an x, right? So y-intercept would simply be y is equal to 3 raised to the power of 0, right? Plus 2 minus 1. So 3 raised to the power of 0 plus 2 is 9. 9 minus 1 is 8. So your y-intercept is 8. So that's here. Okay, maybe I can just write that here. Okay, you guys get the point. And then now we need to look for x-intercept. So for your x-intercept, it's going to be a little bit tricky because your x is actually an exponent as opposed to, just having it as a variable right here. So in that case, you would have y, which is equal to 0, and that's going to be equal to 3 raised to the power of x plus 2 minus 1, right? So what you do is you take negative 1, you move that over to the opposite side of the equation, or you transpose that. This is going to be equal to 1, and that's, sorry, I guess you cannot see the y-intercept. There we go. So for your x-intercept, going back to this, I said that we need to move negative 1 to the opposite side of the equation, and then you get 3 raised to the power of x plus 2, right? So how do you bring down your exponent, right? So that's where the log comes in, or logarithm. You're going to have x plus 2 times, right? You can take log of 3, right? That means log of base 10 or log 3, right? And then you have 3. So right now I'm just going to use log of base 10. It doesn't really matter. So in that case, you're going to divide both sides with log of 3, right? Because you want to isolate just x. Actually, hold on. Yeah, just divide both sides with log 3. You don't really need to expand this, right? So log 1 is actually 0, so 0 divided by whatever log 3 is. You're going to get 0, which is equal to x plus 2, right? Moving 2 to the opposite side of the equation, you're going to see that x is equal to negative 2, right? So in that case, your x-intercept is going to be right here, which is negative 2, right? So you know that your function is approaching negative 1, so you're going to graph something like this. Okay, this is passing 8, guys. You get this, right? And this is 2. That's how your function should look like. Great. Okay, so for part F, we need to solve for, we need to graph this function basically, right? So when you're graphing this function, now it's log, right? So what did I say about log versus exponential function? It's an inverse, right? So we have a vertical asymptote, but here's the thing, you need to make sure you know what the domain is, right? And what the range is. And also, actually, for all of your graphs here, right, you also have to identify what the domain is and what the range is, right? So the range here, we can probably go over that really quickly. Range is going to be all reals, right, in this case. And your domain is going to be all reals as well, all real numbers, because your function is a polynomial function, and similar for part B, right? You know what, let's just do that. And let's have a red pen. Okay, so the domain for this thing is going to be, so this is for part A, so domain, we have all real numbers, right? And then for our range, it's also all reals, right? Or you can just say negative infinity, comma, positive infinity, right? It's the same thing. And then for part B, because it's a polynomial function, it's also going to be domain, which is equal to all real numbers, and range is all real numbers. Okay. And by the way, if you're curious, let's see if we can write this in interval notation sign, because I know for advanced functions it's pretty popular. So you would just have to write negative infinity, comma, positive infinity, right? So that's your interval notation. Similarly, you can apply this here. So for a rational function, right, because we have a vertical asymptote and we do have a horizontal asymptote, so when you write your domain is going to be all real numbers. However, you're not including 0, right? Because you're looking at, actually 1, because you're looking at your x value right here. So it's all real numbers, right? Anything but except 1, right? Because you don't have a function at x is equal to 1. So you're going to exclude that. And then your range is going to be all real numbers except 0, right? Because it's everything and you don't have any of your function on y is equal to 0. So that's how this works. Similarly for part D, it's going to be the same thing as this one. However, your 1 and 0 is going to be different. So domain is, let's see, domain is all reals except your x. So your x here in this case would be -1/2. And then your range is going to be all real numbers except 5/2. Because your 5/2 is your y, which is your horizontal asymptote. Okay. Now, for this thing, right, your domain is going to be all reals. And then your range is going to be, okay, so because if you look at your function, right, it's not going to be all reals anymore. If you look at your function, your horizontal asymptote is basically at -1, right? So you're only seeing your function if it's at -1, right? And then basically it's anything that is above that, right? Okay, so let me rephrase that. You're not seeing your function at -1, but you're seeing your function above -1. So that means you're not including -1. So this is not a square bracket. So that's the difference between drawing a round bracket versus a square bracket, because if you have a square bracket, that means you're seeing that your function is also included, right? But your function is not included, therefore it's going to be a round bracket. And this is round -1, comma, positive infinity, right? Because it goes all the way up. All the way up until infinity, positive infinity. So that's your range. Now, if we're looking at logarithms, right, you need to figure out what your domain is based on your 8x squared, right, which is your x value. So we're going to set up 8x squared greater than 0. And how do I know that this needs to be greater than 0 and not greater than or equal to 0? Well, if you have log 2, 0, that means it's undefined, right? You cannot have your function at x is equal to 0. That's why it needs to be greater than 0. So when you divide both sides with x, you take the square root afterwards, right? You're going to see that x needs to be greater than 0, and therefore your domain is x greater than 0, right? So, as a result, we're going to have x is equal to 0, which is our vertical asymptote, and then we all have to figure out our x and y intercepts from there. We don't have any horizontal asymptote here, so we do need to figure out, first, let's figure out our y-intercept. So y-intercept here, if you have, let's say 0 here, right? First of all, you don't have any y-intercept, and the reason for that is because if you plug in 0 in your x squared, you're going to see that it's 8 times 0, right? So we cannot have this as 0, therefore you don't have any y-intercepts, right? That's why it's none. Again, as a reminder, there is a difference between saying you have 0 as your y-intercept versus none, so make sure you pay attention. And also for x, right? So for your x-intercept, we need to kind of do a little quick calculation on the side. So for your x-intercept, you need to plug in y is equal to 0, right? So 0 is equal to log of 2, right? And then you have 8x squared right here. So I tell my students that anytime you're solving for x in a log function, you need to remember that we have what you call this kind of template again. You have y is equal to log a of x, right? And then you have ay, which is equal to x. Because remember, they're inverse of one another, so that's why you can actually solve your x value based on your exponential function. So as you can see, your a here is 2, right? So 2, right, raised to the power of y. So what's your y? Your y is 0, right? As you can see. Therefore, if your y is 0, that becomes the exponent. So 2 raised to the power of 0, and then whatever your x is, that's 8x squared, right? That's going to be right here. And then you're going to drop the log. So we know that 2 raised to the power of 1, or any number raised to the power of, sorry, did I just say 1? Any number raised to the power of 0, right? 2 raised to the power of 0 is equal to 1, right? And then you're going to have 8x squared, dividing both sides with 8, and then you take the square root subsequently, you're going to get x is equal to, okay, square root of 1 over 8 is square root of 2 over 4, right? So this is approximately 0.354. Okay, so when you graph that, maybe we can have that right here on the side. Oh, actually, this is where our graph is now. So our x-intercept is somewhere here, right? Which is square root of 2 over 4. And the reason why, if you notice, I like to keep my answers in fractions or rational numbers is because a lot of teachers that I know, even when I went to school, my high school teacher specifically told us that we cannot have decimals because we're already in grade 12. So that's the reason why. But I just like to keep it as decimals because I think it's just easier for you to know if it's greater or less than, as opposed to just looking at rational numbers. So you have square root of 2 over 4, and then what's happening here is you're going to just graph it something like this. So it's approaching, so your function, as you can see, it's approaching x is equal to 0. So that's your log function. Okay, great. Maybe we can finish one more question, which is part G, before we end today's class. Okay, so this is, as you know, this is a trig function because you have sine, right? I'm just thinking maybe we can, if we can fit, yeah, we can fit this. Okay, we got this. Maybe we can just use a different pen so everyone can see that. Okay, so to differentiate what we wrote here, okay, let me just move this here. By the way, how are you guys holding up? I know this is a lot, but we need to get through this. Okay, we have sine, right? Okay, 3 more minutes and let's finish this question. So first of all, when you're drawing trig functions, you need to have you need to figure out what your amplitude is, which is a, right? You need to find what your k value is, and you need to find your period. So period is equal to 2 pi over k, right? So k is your constant right here. So, or coefficient. So your 2 is your amplitude, right? Right off the bat, we see that a is equal to 2. And then you don't really have a k, which is, actually, you do have a k, which is 1, right? Again, there's a difference between none and a numerical value, so it's 1. K is 1. And then our period is equal to 2 pi over k, which is 2 pi over 1, which is exactly 2 pi, right? So I don't have to write the 1. And then they're saying that the restriction is basically from negative 2 pi, which is negative 360 degrees, and it's in between, sorry, so your function is in between negative 2 pi and 2 pi, right? So when you graph this, right, so first of all, our sine function, I'm just going to draw that really quickly here. Typically, our sine function, you would have y is equal to sine x, and then you know that this is going to be 1, and then at the bottom you have negative 1, right? So in that case, you need to remember this because when you're drawing trig functions, it's very easy if you know the template or how it should look like, right? So 1 period for sine x is actually 2 pi, right? So in that case, when we're drawing this, because we know that this is x is equal to pi over 3. So our c value is pi over 3. We're going to have pi over 3 somewhere, right? So let's draw that. And also, because your amplitude is 2, that means you have 2 and negative 2 as opposed to 1, right? So that means it has to go up until 2 and it has to go down until negative 2. So your pi over 3, because we're translating to the right, that means we're moving, right? Because x is equal to pi over 3, so we're starting at pi over 3. Okay, that's where pi over 3 is, and then basically we need to figure out what's the next period after pi over 3. So what I like you to do right now is make sure your calculator is in radians, not degrees, and then you type in pi over 3 plus 2 pi. Okay, so you're gonna get 7 pi over 3, right? So we know that that's one period. Oh, great. Make sure it reaches 2. So one period is going to be 7 pi over 3. Okay, does that make sense? And then basically, how do you figure out what this is? Well, all you have to do, because you know that one period is 2 pi, just add pi over 3 plus pi. Okay, let me just quickly do that. Yeah, so that's 4 pi over 3, right? So this is 4 pi over 3, but we don't really need that information. And then, because it's from negative 2 pi to 2 pi, right? So just make sure you also draw things that are on the left side, right? So in that case, if you want to figure out what one period is coming from the left side, all you have to do is make sure you have the pi over 3, and then I typically add that to 2 pi. But in this case, because it's on the left side, you need to subtract. So pi over 3, let's try this, minus 2 pi. You're going to see that you're going to get negative pi over 3. Negative 5 pi over 3, right? Okay, so let me repeat that one more time. In order to find what the period is on the left side, all you have to do is you take pi over 3 to begin with, because that's your c, and then you subtract negative 2 pi because that's your period. So when you do that, you're going to get negative 5 pi over 3. So that's one period, and then this is gonna go and cross. There we go. Okay, I know it's a little bit off, but that's how your function is supposed to look like. Okay, that's one period. Okay, first of all, this is supposed to reach 2, right? Oh my goodness. Okay, we can do this. Okay, just imagine, guys, that this is at 2, right? Right here. So this is 2. So that's one period, right? And yeah, so this is basically your graph for this function. And because they're saying it's 2 pi, right? So maybe let's just quickly go over this just to make sure that when you draw the graph, it's within the restriction. So 7 pi over 3 is actually 420 degrees, right? If you calculate that. So that's actually more than 360 degrees. So you really need to stop at 2 pi, right? Actually, you can stop here because it's like one period, right? So pi over 3 plus 2 pi. So you're going to stop here and then you're going to stop right here. So that's fine. Okay, so we've covered everything so far. And then for the next class, we can just go over h and oblique and slant asymptotes, and then we'll continue on with advanced functions. So if you do have any requests, please reach out to me. I know that there's probably going to be a lot of you, so just make sure, because I also love to hear from my students, right? So, and yeah, thank you so much, guys, for tuning in. And if you're interested to watch more of my classes, not just advanced functions, and in fact, I'm hosting a calculus class this afternoon at 2 p.m. So make sure to 2 p.m. EST. So make sure to stay in touch with me by checking out my daily schedule at oneclass.com/livestream. So that's where you can check my daily schedule for my classes. I host math and chemistry again. And if you have any friends who you think might benefit from this, please call or text them and make sure to ask them to come join too. So I'll see you on my next class. Bye, guys. Hi everyone, this is Janine Ko, aka Janine the Tutor. As you all know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of one class, we are very fortunate that we are able to adapt to the situation quickly. And because we want to help students stay on top of their studies, that's why we're running daily and free classes for math and chemistry from grades 11 to first year college and university. In addition, we are also offering and giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, I will be going over advanced functions or pre-calculus. And we're studying this course collectively because I just think that the best way to learn advanced functions or pre-calculus is to really combine all of your types of functions and be able to evaluate them. Can I get a yes if you can see my screen? And if you can hear me coming through as well? Okay, so let's begin. So the first question we need to figure out whether the function is even, odd, or neither, right? So just as a recap, first of all, how even versus odd, right? So if a function is even, that means algebraically, you're going to have to plug in f of negative x. So if it's even, if you plug in f of negative x, you need to have f of x. So that's when it's even. And if it's odd, you need to plug in f of negative x as well. But instead of to have negative f of x. Does that make sense? And the reason for that is because if you're looking at an even function, so say for example, let's start with the basic. We have y is equal to x squared, which is a parabola. We know that this is an even function. So you're going to have this graph right here. So this is y is equal to x squared. And if you think about the symmetry, there we go. So this is an even function. So if you think about the symmetry, that means your function remains unchanged if it is reflected on the y-axis, right? So if you think about this y-axis as sort of like a mirror, so when you flip this part, right, it becomes the exact same reflection, right? So it's symmetry around the y-axis, but for an odd function, let's say you're looking at y is equal to x cubed, which is a cubic function. Okay. So your symmetry is actually 180 degrees, right, over here, and you have a point symmetry to be specific right here. So when you kind of rotate this, right, 180 degrees, so you're looking at from here, rotate that until here, right, 180 degrees, you're going to see that your function remains unchanged. So that's the difference between even and odd functions. And that's why you have this positive symbol right here versus the negative sign right here. Okay, so hopefully that was clear. But for this three questions, A, B, C, all you have to do is really evaluate whether you're going to have f of x as a result, which is the exact same thing as your function, versus if you can take out the negative sign and then you're going to have your function, f of x. Okay, and if it's neither, that means it's not going to be any of the two, right? So let's start off by plugging in f of negative x right here. Okay, so we do have 1 over negative x, and then you need to cube this, right? Plus 1. So if you think about cubing negative 1, right? Because this is a negative 1 coefficient, we can actually say that this is going to be 1 over negative 1 cubed. So we're taking out that cube, and then we're left with x, right? Plus 1. Does that make sense? So This should still be cube, right? Because we're still copying that cube because it's raised to 3, but then we're taking out the -1, and as a result, we know that any negative number raised to an odd exponent is always going to be negative, right? So therefore, we're going to have negative, right? So this -1, you can have that outside of x cubed. So you're going to have x cubed, and this is going to be +1. Okay, so if you think about this negative x cubed, right, this is not really outside of your function. It's actually just beside x cubed, right? Because if you have to take out the negative sign or factor out the negative sign, you're going to have negative, right, 1 over x cubed minus 1, right? Because the negative sign gets distributed if you have this right here, so you're going to get negative x cubed plus 1. So as a result, you're going to say that this function is neither. And why is it neither? Well, if you look at your function, right, your f of x originally is 1 over x cubed plus 1. And this negative sign right here, if it's odd, that means you're going to have this negative sign outside, but you need to exactly have the same function, which is f of x, right? But is it the same function? No, because you have a -1 here as opposed to +1. That's why it's neither. Okay, hopefully that makes sense. Moving on to part B. We have 2x raised to the power of 4 plus 3x squared. So when you plug in -x, so same thing, raised to the power of 4 plus 3 times -x squared, you're going to see that you have even exponents, right? So what's the rule when your coefficient is negative, right? Or any number really, when you raise it to an even exponent, right? It's always going to be positive. Okay, so as an example, if you type in -2, right? We know that, let's just keep it as -1, just so it's simple. Okay, so this is -1. If you raise this to an even exponent, let's say 4, right? Type this into your calculator, you're going to get 1, right? So that means anytime you have a coefficient or a number raised to an even exponent, it's always going to be a positive number. So in that case, you're going to get exactly 2x raised to the power of 4 plus 3x squared, right? And as you can see, 2x raised to the power of 4 plus 3x squared is exactly the same g of x, right? To begin with. So therefore, since we know that g of -x is equal to g of x, we can say that our function is even. It's not too bad, right? All you really have to do is plug in your -x. Okay, so moving on to h of x, which is 1 over x cubed plus x raised to the power of 5. So here's the thing, because you have raised to the power of 5, it gets a little bit tricky, but you're going to do the same thing so it's the exact same thing as the other two that we did. So you're going to plug -x. So you're going to have h of -x, and that's equal to 1 over -x cubed, and this is going to be plus -x raised to the power of 5. Okay, there we go. So as a result, right, remember what I said about if you have a negative coefficient, you're raising it to an odd exponent. Therefore, the number would remain negative, right? So that's what we're going to do. So we have 1 over, this is going to be -x cubed, right? And then we have -x. Okay, so from there, we can take out this negative symbol or negative sign, right? Such that this is now going to be negative, right? And by the way, because you have 5 here, we can say that this is -1 raised to the power of 5. Because remember, you're taking the -1 out from an exponent of 5. So you need to make sure you have that 5 there. And then you can rewrite this as 1 over x cubed plus x, right? Raised to the power of 5. Okay, so there we have it. And then now you can see that again, I've probably said this so many times now, but if you have a coefficient that is a negative number and you're raising that to an odd exponent, that means it becomes negative, right? So you're going to have this negative 1 here because of this odd exponent, and then you're going to have 1 over x cubed plus x raised to the power of 5. So as you can see, you have a negative sign out here when you plug in h of negative x, right? You're getting negative of h of x, which is an odd function, right? Because going back to this, what did we say? If it's an odd function, if you plug in negative x in your function, if you have a negative sign and if you're getting the same exact function, which is f of x, you're going to have an odd function. Cool. Again, as a reminder, all of my sessions are recorded, so you don't have to quickly jot everything down. Just take a seat, take your calculator out, plug in the values, calculate them with me, and just pay attention. So for number 2, it says graph the following functions. You have y is equal to negative x times x minus 3 times x plus 4. Okay, so we're just going to do a recap with multiplicity and degree, and also the sign of your leading coefficient. So those are the 3 things you have to remember if you're graphing functions, and specifically they're polynomial functions, right? So this is a polynomial function. So first, let's identify 3 things as I mentioned. So if you're looking at this negative sign right here, that indicates that you have a negative leading coefficient, right? And you're probably wondering right now, what does the leading coefficient and its sign has to do with drawing or graphing the function, right? So if it's a negative leading coefficient, so we're going to have that right here. So leading coefficient. So if it's a negative leading coefficient, that means when you're graphing your function. So for example, if you're looking at a linear function, which is y is equal to x, say for example, versus y is equal to negative x. So we know that if you're graphing y is equal to x versus y is equal to negative x, if it's a linear function, that means your line is passing quadrant 3, right? Because this is quadrant 1, 2, 3, 4. Versus something like y is equal to negative x, which is quadrant 2 and quadrant 4. Does that make sense? So the negative leading coefficient or the positive leading coefficient would determine whether your function is passing quadrant 1 and 3, if it's let's say y is equal to x, versus quadrant 2 and 4 when it's a negative leading coefficient. Same thing really applies for example, y is equal to x cubed, right? Which is what we know is an odd function, right? So we have something like this. So we know that it's quadrant 3 and quadrant 1 when it's positive, and if it's negative x cubed, we know that this is quadrant 2 and quadrant 4. And guess what? It's similar to y is equal to x squared, right? So let's just scroll down just to see and compare them. So y is equal to x squared. This is going to be on quadrant 2 and quadrant 1, right? And if you have y is equal to negative x squared, you're going to have that on quadrant 3 and quadrant 4. Does that make sense? So it matters where you're going to graph that. Okay, so I can erase this now. So that's for the sign of the leading coefficient. So let's move on to multiplicity versus degree. So you've probably heard what multiplicity is, and also zeros, right? Zeros and multiplicity are related to one another. So for example, you're looking at x, right? So first of all, you have x, you have x minus 3, and you have x plus 4, right? So your zeros are going to be 0, right? Because x is a 0. And you have positive 3 and negative 4. So maybe we can just group this based on the smallest versus the largest. So we have negative 4 to begin with because it's x plus 4 is equal to 0. Therefore, you're going to get negative 4, right? And then you have 0, comma 3, right? 0 for your x minus 3 is equal to 3, right? So in that case, you're going to see that the multiplicity of x plus 4 is going to be 1, right? So what is multiplicity? So multiplicity is when you're looking at different terms, and then you call this sort of like an exponent. So if you look at x plus 4, your exponent right here is actually 1, right? So the multiplicity of negative 4 is actually 1. Multiplicity of x minus 3 is also 1, right? So let me erase this so you can see everything. So this is 1, right? This is multiplicity of 1, and this is also multiplicity of 1 because all of your exponents are actually 1. Does that make sense? Okay, so multiplicity is 1, 1, and 1, right? However, if you're looking at the degree of your function, that means the degree is your summation of all your multiplicities, right? It's going to be 3, right? Because 1 plus 1 plus 1 is 3, right? So the degree of your function is 3. Okay. So why does the degree matter? Well, the degree matters because at least you know which quadrant it passes through, right? Because if you're thinking about an odd function versus an even function, right? This is what I tell my students to really remember during the test. So if you're looking at, let's say, a negative leading coefficient, if it's an even function, so say for example, you have negative x squared, right? You would have to, so this is the one that we talked about earlier, you would have to look at quadrant 3 and quadrant 4, right? So you know where your function is going to start and where it's going to finish. So it's going to start at quadrant 3 and then you're going to finish at quadrant 4. So that's the position of where you're going to draw. However, if you're looking at y is equal to negative x cubed, you know that it's not at quadrant 3 and quadrant 4 because it's actually at quadrant 2 and quadrant 4. Does that make sense? So when you draw this graph, you know that if it's degree 3, therefore it's an odd function, right? And if it's an odd function, you're supposed to expect that this is what the quadrants, or this is how your graph is sort of going to look like. So these are what you call like templates that I like to tell my students to remember during the test. So you have an idea of where you're going to start drawing the graph, because otherwise it's just going to be overwhelming. Okay, so now that we have that, we're going to have a number line, and then you're going to graph all of your, sorry, not graph all of your zeros, but plot them, right? So this is negative 4, 0, and 3. Okay, so we know that this is all of your zeros, and then first of all, because it's a negative leading coefficient, it's an odd function, you're supposed to start on top of your x-axis, right? This is your x-axis. And then because you know that the multiplicity of x plus 4 is 1, that means you're going to cross, right? Okay, so here's the thing. If you have an odd exponent or odd multiplicity, you cross. Okay, maybe we can just write that here. So odd multiplicity, that means anytime you have an odd number and it's multiplicity. So say for example you're looking at 1, 3, 5, 7, right? All of your odd numbers, you're going to cross your x-axis. And if it's an even multiplicity, you're going to bounce, right? So you're only touching, you're not crossing. Okay, so let me just abbreviate that. So cross, and then you're going to bounce, right? So in that case, you're going to cross. You're starting from quadrant 2 because you know it's a leading coefficient of a negative sign. So you're crossing this, right? Again at 0, because its multiplicity is odd, you're going to cross this again, right? And then you're going to cross another one for 3, right? Okay, there we go. So this is how your function is supposed to look like. So you're just crossing, right? But, okay, moving on to part B, right? If you're, let's say your exponent or multiplicity in this case is odd, but it's greater than 1, you have what you call an inflection point. So instead of just crossing, so say for example, let's plot this together. So we now have positive leading coefficient. Okay, I'm just gonna abbreviate coefficient as co-f, but that's coefficient. And your zeros are essentially -3, right? X plus 3 and +2, right? And then your degree now is going to be 5, right? And the reason why it's 5 because it's 2 plus 3, right? So degree is the sum of your multiplicity. In that case, because it's an odd function,